Don't rush to throw away your old spark plugs. This spark plug spent years inside an engine. Most people would remove it during maintenance and immediately toss it into the trash without giving it a second thought. But today, we're going to take a closer look at what's actually hidden inside this small piece of metal and ceramic. I have an idea that I bet 99% of people have never considered before. If everything works as planned, this old spark plug is about to become a useful tool once again. And honestly, the results surprised me. Let's get started. The first thing needed is a short piece of electrical wire about 4 inches long. Using wire cutters, I remove a small section of insulation from both ends. One exposed copper end is wrapped tightly around the threaded body of the spark plug. The other end is connected to the ignition terminal at the top. This creates a continuous electrical path through the spark plug assembly. With the first connection complete, it's time to build the main power lead. For that, I prepare a second wire about 12 inches long. One end is stripped carefully. The copper strands are twisted together and attached to the ignition terminal assembly. Again, the connection is tightened firmly. Good conductivity starts with good contact. Now I need a handle. A short piece of plastic pipe works perfectly. Plastic is lightweight, inexpensive, and most importantly, it provides electrical insulation. The wire is fed through the center of the pipe. Next comes a quick test fit. The spark plug is inserted into one end of the pipe. Immediately, a problem appears. The fit is too loose. The spark plug wobbles inside the handle. If left this way, the entire tool would feel unstable during use. So instead of forcing it, I solve the problem first. Several layers of electrical tape are wrapped around the spark plug body. Each layer increases the diameter slightly. After a few wraps, the spark plug slides into the pipe much more securely. Now the handle feels solid. No movement, no rattling, exactly what we want. The remaining end of the wire is connected to an alligator clip. This clip will eventually connect to our power source. At this point, the basic structure of the tool is complete, but it still needs a working tip. And that's where this old battery comes in. Most people see a dead battery and assume it has no value left, but hidden inside is something surprisingly useful. Using pliers, I carefully remove the outer casing. Then I pull apart the internal materials. Inside, there's a carbon rod. That's the component we're after. Carbon has several useful properties for this project. It conducts electricity, it tolerates very high temperatures, and it doesn't melt easily under the conditions we'll be using. Have you ever opened an old dry cell and seen this black carbon rod inside? Let me know in the comments, because most people have no idea it's even there. Now, I want to turn this carbon rod into a working tip. The rod is mounted into a drill chuck. Then a piece of sandpaper is held against the rotating carbon. Slowly, the shape begins to change. The spinning action makes shaping much faster and more consistent. After a few minutes, one end becomes noticeably pointed. That sharp point serves an important purpose. Now everything needs to be connected together. For this step, I use a small copper terminal connector. Copper is an excellent conductor and provides a strong mechanical connection. One side of the connector is attached to the spark plug. The carbon rod is inserted into the other side. Then both screws are tightened carefully. Alignment matters here. A crooked tip would make the tool harder to control. After a few adjustments, everything sits perfectly straight. The tool is finally complete. Now comes the exciting part: testing. For this demonstration, I'm using a 12-volt power source with thick wires and very short contact time. This tool can draw a lot of current, so I'm also using eye protection and keeping my hands away from the metal parts. Never hold the connection for too long, and never leave this tool connected when you are not using it. The carbon point is brought into contact with the circuit. Immediately, a bright spark appears. The tip begins glowing red. That's a very good sign. The system is working exactly as intended. Within moments, heat begins building at the connection point. The copper softens and bonds together. After cooling, the connection feels surprisingly strong. This demonstrates one of the biggest advantages of focused heat. Instead of heating a large area, energy is delivered exactly where it's needed. But let's try something more challenging. Battery cells are often difficult to work with because excessive heat can damage them. Fast heating is important. The contact point is positioned carefully. The carbon tip touches the metal surface. Heat develops quickly. The connection forms before excess heat has time to spread through the entire cell. After cooling, the joint feels secure. For a homemade tool built from discarded materials, that's an impressive result. Looking back at this project, it's hard to believe where everything started. An old spark plug, a dead battery, a few scraps of wire, materials that most people would never think twice about throwing away. Yet, with a little creativity and some basic tools, those discarded parts have been transformed into something useful again. That's one of the things I enjoy most about projects like this. They remind us that many objects still have value long after their original purpose is gone. Before we finish, let me know where you're watching from. I'm always interested to see how many different countries and communities are represented here. And if you've ever repurposed an old automotive part into a useful tool, share your experience in the comments. If you enjoyed today's project and found it useful, don't forget to like and subscribe. Thanks for watching, and I'll see you in the next video.